Hydraulic fracturing by Liz Trapp.
How does it work?
That's a good question.
As a means to retrieve previously inaccessible natural gas lying under 1,000 feet of dense rock, the modern technique of hydraulic fracturing was implemented. Hydraulic fracturing, or fracking, as more commonly referred to, is a drilling method that utilizes highly pressurized fluid forced underground to create fractures in dense rock formations, large reservoirs of natural gas lying below it, hence its name. This relatively new means of natural gas extraction has been met with much controversy, despite its uses. As you can see in the picture, a well is dug to the specified height in which the gas is located. Once the well reaches its depth, it is coated with a layer of protective concrete to ensure that the well does not collapse on itself. Then, a military-grade explosive device is lowered down the well and detonated in the rock to create the fissures seen in the diagram. A proppant is then injected into the fissures to hold the fractures open. The fracking fluid is most commonly composed of water and sand, but it has been known to have hydrochloric acid, glutaraldehyde, and quaternary ammonium chloride to aid in the fracturing of the rock, as it corrodes and makes it easier for the pressure to open up the shale rock. While these chemicals can be harmful, it only takes up a small percentage of the actual fluid. The fracture gradient required to break up the rock formations increases downhole, meaning the lower the fracture, the more pressure is required of the fracking fluids to actually break up the rock. The gas then flows out of the well and is placed in storage tanks, eventually leading it to the market. This diagram shows the protective coating of cement placed in the well, as well as the explosive device used to create the fractures. If you look closely, you will note an extra layer of steel and cement casing placed around the well that is in the groundwater aquifers. This ensures that none of the fluids, either being recovered or pumped into the ground, will seep into the water that is accessible by both humans and animals. This next slide shows the composition of the fracking fluid, which is injected into the well. As you can see, the majority of the fluid is made up of water, which is not harmful material, but there are other chemicals used in it, such as acid, corrosion inhibitor, friction reducer, clay controller, crosslinker, scale inhibitor, breaker, ion controller, biocide, and gellant, but these only make up 0.79% of the actual fluid. While it's easy to see the harmful effects should one of these materials seep into our water sources, the actual amount used in the fluid is so minute and the precautions that are implemented are so effective, the actual possibility of water sources being contaminated are slim to none. When a well is dug, precautions are made to ensure the safety of both humans and animals alike. As such, the actual drilling that takes place generally occurs 10,000 feet below the underground aquifer. The well passes through the water table into the fracking zones, which is where the fractures occur. The fluid is then released into the rock layer, and the fluid flows back up through the well to be collected above ground. While it is improbable for the chemicals in the fluid to seep 10,000 feet back up into the water table, the chemicals are now in the rock layers, and there's always that 1 in a million chance of it being contaminated and then released into the wildlife and humans. This map depicts areas that have experienced contaminants within their water supplies. As you can see, a majority of the contaminations have occurred in the northeast region. While this poses a harmful threat to its water supplies, a natural occurrence of the decomposition of organic material in the water have produced methane within wells. This natural occurrence has led to the contamination of water, however, it's not to be overlooked because it is a natural occurrence. While hydraulic fracturing has been said to be beneficial to the oil industry, there have been several repercussions to the environment that have been noteworthy events. The gas being recovered downhole is under constant pressure and temperature, which is exerted on its molecules from being deep within the Earth's crust. According to kinetic molecular theory, its depth causes fast and frequent collisions between the gas molecules. After the gas is removed through the process of fracking, the pressure the gas exerts is decreased, allowing the sediments in the rock layers to shift. Recent investigations have shown that 5 earthquakes have occurred at the Napoleonville Salt Dome in northern Assumption Parish. These are believed to be the result of government-mandated fracking, and as you can see in the diagram, a sinkhole was created where fracking was occurring nearby. Another impact fracking has on its environment is the reduction of air quality. Fracking requires machinery that has been known to give off smog emissions that have been proven to be detrimental to the health of humans and harmful to animals. Not only are humans affected by natural gas extraction, but animals are too. They rely on sources of water that are sometimes near to a fracking well. Each well is capable of producing large amounts of wastewater that can be filled with corrosive salts and carcinogens, which are radioactive materials. Those who are against fracking claim that the chemicals from the fracking fluid seep into underground rivers or aqueducts, which then in turn pollute sources of water above ground. Once the pollutants are in the water, accessible by both humans and animals, there is a possibility of the pollutants transferring to the consumers. In an effort to ensure the safety of the public, several bills have been implemented to regulate fracking. Some of this new legislation is the Fracking Responsibility and Awareness of Chemicals Act, or FRAC for short. This would limit the range of drilling that could occur within the proximity of both private and public wells, springs, and reservoirs to ensure that no chemicals seep into the water that humans and animals could drink. However, some states have decided to forego the tedious task of passing this legislation and have instead banned fracking altogether. So, why should hydraulic fracturing remain an active means of natural gas extraction? Is the impact on the environment too great to outweigh its benefits? Although any number of environmental outcomes could have resulted from fracking, there are positive implications for fracking. It is easy to see the harm that could come should enough chemicals find their way into a source of water, and you can empathize with the opponents of fracking. But there are other means for fracking other than natural gas extraction. It can be used to measure the stress in rock formations, produce electricity, stimulate wells, enhance water remediation, and even precondition rocks for mining. So ask yourself, is it worth the risk?